Okay. So the first part, so the title, general title is Innovations in Sustainable Energy Conversion Technologies, so in particular, as already mentioned, wind turbine and hydroelectric resources. We are not focusing on photovoltaic panels like so the solar energy. Is another aspect that it is investigated from some colleagues of mine, but is not really the main issue of our resources that are focused mainly on wind turbine. As I already mentioned, so you have here my email and the general link to the talk. So let's start with the wind turbines. So there are several discussion topics. So we will start with the general considerations, and I will revise some advanced control because it's from one side the model of these systems is quite known, but in the last, let's say, there was a very high research interest in starting about, I remember, 15 years ago, when it was also, I will mention it later, when the general benchmark and also an international competition was proposed by in the literature, also connected to different conferences. And so it was really interesting, this topic, at least all the applications that several researchers proposed for this benchmark. And it was interesting because we started in 2009 with the definition of this benchmark from a very simple wind turbine. And this competition continued through the development of a more detailed model of this benchmark. And then another, I will mention again later, but it was proposed by a company in Denmark. They made also available freely a model with this wind turbine, and it was made also more complex. And then they developed a wind park, so it was a system with 9 wind turbines. It was really challenging, well, from one side, and from the other side it was a little bit simple, but with this system, you can also validate your solutions that you propose. So the idea, it was to develop some, as is written here, some sustainable structures in order to, so the idea of sustainable, as it will be described later, means that this process, this plant, needs to continue to work even if some unexpected faults, so malfunctions in general, are affecting the system. So we will also investigate, I will just mention some modeling issues regarding wind turbine, and then we'll finish the first part of this discussion with this general remarks. So in this picture, we have the early wind power development. As you can see here, they were very simple, very basic plants with a different number of blades. So in this picture, you can notice 6 blades, 4 blades. So normally they were connected not really for the production of the energy, but for the development of mechanical energy that it was used, for example, for grinding or for mechanical processes. So in fact, the first wind turbine was in 1888, and it was, so we need to wait for the development of a DC generator before they can be used for producing energy. And so it was the first plant was in Cleveland, Ohio. So the idea of the wind energy function is quite simple, because you have from the left side you have a wind turbine generator. So you can see here you have the blades. Normally you have 3 blades because they are so you have a good balance with this system. You can see they tried also with 1 blade or 2 blades, but especially for the one blade system was really difficult to be maintained, because it's due to the imbalance of the nacelle. We will see later. So normally in the nacelle, which is the main, is the core, it represents the core of your wind turbine. You have a gearbox which transform normally the speed from a low speed of the blade shaft to a higher speed of the generator shaft here, and then so also the torque is modified in order to run the electric generator. There is also here, you can see there are 2 gears that are used for moving the nacelle in order to face always the direction of the wind. So then you transport your energy in the transformer here, in the transformation module. Normally is transformed into a higher power energy, and then it can be distributed in the around. So the wind energy is the process, of course, is very simple, which is used to generate mechanical energy or and transform normally into electricity. So in principle, the principle is very simple. It's from the physical point of view, it's used to convert kinetic energy into mechanical, which was, as I already mentioned, so the first application was like a grinding process. From mechanical, and later, so the end of the 18th century, to the electrical energy. There are different kind of blade designs. For example, you have on the left side what we call horizontal axis wind turbines, because as you can see here, you have the blades that are placed in this way. So normally they are used in, for example, there are small applications placed in the civil environment. They are normally rotating with a low speed. And then we have, this is a vertical axis wind turbines. And then here we have the horizontal. You can see here an example of 1 blade, but normally is, of course, is simpler because you have just 1 blade. But of course, on the other side, you must guarantee the balance of the system. So you need to adopt some technical solutions for balancing the
Sorry, I interrupt you. Can I ask a question?
Yes, of course.
In this case, based on your explanation, you have a vertical and horizontal kind of the wind turbine.
Yeah.
In this case, which one is the better performance if you want to install it in this, the places? Generally, you can imagine at the same situation or condition better if you want to install vertical or horizontal wind turbine. Which one is the better performance? We can achieve the more energy with the help of this kind of the wind turbine.
Yeah, normally, thanks for your question. Normally, for high performances, if you want to achieve higher performances, of course, the horizontal axis wind turbines are the most performing systems. On the left side, so the vertical axis are normally used for example, when you need small or low energy applications, like in the farms or in small civil areas. Maybe you have normally the generated power is lower than, is around of the order of magnitude of some kilowatts. But if you need to generate and to produce more energy, I mean on the order of megawatt or gigawatt, so you need to use horizontal axis wind turbines. So it's,
you mean that, sorry to interrupt you again, in this case you mean that if you want to use the horizontal actually wind turbine, the performance will be maybe 2 times more or 3 times more than the horizontal?
No, sorry. The horizontal, the horizontal on the left is sorry. The vertical, sorry, on the left is the produced power is lower. Let's say
lower.
Lower.
How much does it lower than the horizontal?
A couple, let's say, from 10 to a couple of order of magnitudes, because normally these systems like this one, it can produce some kilowatts. And
my background is about the computer science, but I'm a big fan of the renewable and also green energy. As a result, maybe during your presentation, I would like to ask some questions because I would like to improve my knowledge about this kind of energy. Thank you so much.
Thank you. And also the horizontal axis, the vertical axis wind turbines on the left are working normally with a lower speed because you can see here it exploits they are used, for example, also on ships or small vessels for producing the local energy. So their use is mainly for producing energy that can be used locally. So there is normally the energy is not moved or transmitted outside. On the other hand, on the right side, the horizontal axis wind turbines are producing more energy. They are placed, for example, as we will see later, on offshore applications. So it means very far from the coast and very high. So the produced energy is also higher, much higher.
Thank you so much for the explanation.
So there are three examples. You have on the sides, on the left side and the right side. Sorry, somebody wants to connect. So on the left and right side, you have what we call Savonius vertical axis wind turbine. You can see from it depends, the different name depends on the shape of the blades. So the Savonius normally works with a higher speed, so it needs a stronger wind to work, but when it starts is able to produce energy. And we have also the second, on the right side, we have what we call Darius vertical axis. Darius vertical axis is able to start with a lower speed of the wind, and so is bigger. So normally we also integrating Savonius and Darius technology. So we have the capability of the Darius wind turbine to start rotating with a lower speed of the wind, and then you have the capability, so the advantages of the Savonius wind turbine to rotate and to produce more energy. So you have the integration of these two technologies. Of course, as already mentioned, normally Savonius and Darius turbines are intended, so they are vertical axis, and they are intended for the production of energy that normally is used locally, is consumed locally. If you need to produce and to have a higher effectiveness on your energy production, you normally use, for example, offshore, onshore, or offshore applications, or also on wind park. On wind park, you normally use horizontal axis wind turbines with 3 blades. So the idea of the rotation, so the physical aspects is very close to the working of an airplane wing. So normally this laminar, the wind flow on your blade, that you see that the blade as an angle, it produces a different pressure on the sides of your blade of your wings. So in this case, depending on the wind flow, it makes rotate this blade. And as you can see here, is the same principle of a wing of the plane, that when your plane is starting, when you are flying, you start to fly, and you have a lift due to the drag of your flow of the air. So it produces a lift, and so the plane is able to take off. And the same power is exploited in the wind turbine. So the blades are starting rotating in this direction, and you can play with the. We will see later. You can play with the angle of your blade in order to control the rotation of your system, which is very important, because you need to avoid, for example, that you do, for example, to very strong wind, that normally the blades that are flexible surfaces bends, and then they collapse, for example, or hit the tower. So it will be very dangerous. So it's a way for avoiding damages to the mechanical structure. Of course, they are not rigid, of course. So normally they bend and they can hit the tower. So it's very important. So let's see some more details on the wind turbines component. We already seen, so there are also some technical names. We have the blades here, 3 blades in this horizontal axis wind turbine. We have the rotor, as you can see here, is the tip where the blades are connected to the principal core. And then we have this is the shaft. The shaft, which is the low speed shaft, because of course you know that the speed of these of the blades is normally it rotates the rotation is very low, several, I don't know, 10 I don't know radians per second, and you have a gearbox. So the gearbox, as you can see here, allows to speed up the rotation. So normally, if this wheel is rotating at a lower speed, there is a smaller wheel that is rotating at a higher speed. So which is required for making the generator to produce more energy. So normally is difficult to see some to find plants that there is a direct connection between the rotor shaft and the generator. Normally there is a gearbox. There is a general consideration, the gearbox is one of the most important elements because also they are mainly affected by faults. The second element, so the most affected elements or modules in your wind turbine that are affected by faults are the generator. Let's say 30% of the faults are affecting the generator, and a lower probability is affecting the gearbox. So normally 30%, about 30-35% the generator, 20-25% the gearbox, and remaining are faults are affecting other parts. For example, we have the controller, the sensors, and there is also here indicated a brake. Brake is used as a it's a way for blocking, for stopping your system when, for example, in case of very high wind, when the blades would rotate very quickly, so we can encounter the problem of for example, that the blades are bending and then they are hitting the tower. Here is included here, the tower. And then we have the yaw, a yaw control. You can see here a yaw drive. You have a motor, normally is an electric motor, which makes the tower rotating, so the blades are always facing the direction of the wind. So this maximizes the conversion of your system, of the wind. So the produced energy, there is here an important, this is like a picture, a very simple picture. There is also is including also a physical law that used for computing, for estimating the produced energy. So in principle, you are considering as a pipe which is generated by the wind. So you are considering just this section of your wind which is hitting the blades. So you are considering the diameter of this disc, is called technically called as disc here, and so it's important the diameter or the radius of your, so the length of your blades. So in principle, as is mentioned here, the turbine blades are removing energy from the wind. So you have higher velocity, higher energy here, and lower velocity, lower energy behind your wind. V is the wind speed. So the generated, you can demonstrate that the power in the wind depends, is a physical law, the density of the air, the turbine. So when you are considering like this pipe, the turbine blade diameter, the velocity of the wind, and a constant. So as you can see here, the power of the wind is important because you can see here that the power, the third power of the wind rules the power, the generated power. So is normally you play with the wind speed. You normally, when you need to install a wind turbine, you must select, you investigate. There are some investigations before you can install a wind turbine. So you need to decide where the velocity of the wind is higher. So it's why normally these systems are placed in, for example, offshore or onshore near to the coast, because, and also the tower is very high, because normally the higher is the tower, the higher is also the wind speed. So it's why normally you have the diameter, of course, is not, cannot be so high, because there are also some physical limitations, but a way for producing more power on your system is to find a place where the velocity of the wind is really high. So this is why normally there is a great attention where you want to install these systems. Well, from the other side, you want to you must consider an environmental impact, because normally you have what we call the disco effect. Disco effect means that the rotation of your blades generates this like of noise with a lower frequency content, so it can be disturbing for the system. So it's why is a motivation for these wind turbines to be installed very far from the cities or the civil areas, in order to avoid to reduce the environmental impact. The second problem, so you can think of installing them, for example, in the open sea, very, very far from the coast, so we call offshore. Well, offshore, you have another problem, because normally you have an impact on, for example, with the sea. You have an interaction also with the waves, which is quite important. So you have a structure that is in the sea. So you must also consider the interaction with the, for example, the habitat, fisheries, also acoustic disturbances generating in the sea, and also because they are connected to transport the energy, so you have also electromagnetic fields that can interact with your environment. So it's another problem that you must consider. As you can see here, as I already mentioned, these vertical axis wind turbines, as you can see here, there are examples of small wind turbines. They can be also...
Sorry, interrupt
yes.
you again. Could you go back to the previous slide, please?
This one?
In this slide, it's talking about the wave, okay? Come from the sea, go through the wind turbine installed near the sea, okay?
Yeah, yes.
Is there any possibility to use at the same time, create the energy with the help of a wave energy turbine and also wind turbine at the same time? You can associate it together. At the end, we will have one unique electricity energy. Is it possible?
So you, I didn't catch your. So you want to join
is it
the?
possible to create the energy with the help of two kind of the turbine? First, wind turbine, and second, wave turbine.
Well, yeah, is a good question. Well, the problem with the wave.
Tell us about the pros and cons of this kind of scenario. Can be do it in order to make energy.
Yeah, is something that we work. We have also a paper on which compares the wind and wave energies. Normally, excuse me, there is somebody who wants to connect. Okay, so normally, as far as I know from the installations, the wave energy generator are normally placed quite near to the coast, because they are exploiting the waves effects, and the wind energy is placed out in the very, very far from the coast. So perhaps you can integrate them, but not in the same area, because you are exploiting.
Why we cannot use
Yeah.
it at the same area? Could you explain?
Because the waves, of course, the waves effect in the open sea is lower than the wave effect near to the coast.
Okay.
I saw some installations, for example, in UK, and
Yes, in UK, yes.
and they are placed very close to the coast.
Yes, exactly. We cannot install a wind turbine near the coast.
No, no. Normally, is you can do it. Normally, they are quite far because you want to reduce the impact. You want to place them in very far from the coast, because the effect of the wind is higher in the open sea rather than the coast.
Okay, thank you so much.
And also,
and also, can we use it? Can we install it this wind turbine in the sorry, in the ocean, something same as I don't know, call it same as oil station, something.
It can be, yeah. It depends, of course. It depends. Normally, you have not single wind turbines, but normally you have what we call wind park. So you need to use a very extended, a huge extended area.
Okay.
So
in your
perhaps,
opinion, is it possible to use the wind turbine and also wave turbine at the middle of the ocean?
you should of course, wind turbines. Yes, I don't know. You can use them. Wave, you need to investigate how the power of your waves, because you have an open sea, and
you must control some wave turbine and also device and equipment, huh?
There is perhaps is more common to see an integration between wind and solar. So you can integrate, for example, the effect of both, because normally you know that perhaps wind is acting at the same time with waves, but is perhaps the power generated by the sun is uncorrelated with the wind. So perhaps it's better to integrate two different.
Did you work on some other kind of the renewable energy, same as some kind of the energy can be created and built with the help of vehicle, something on a street, something?
You mean other
another kind of the renewable energy, same as you mean that
we can
create some electricity energy with the help of a vehicle movement on the street, something.
Well, we make an investigation for some, let's say, 7 or 8 years ago, to exploit for example, the turbulence produced by the vehicles that are running on the street, on the normally highways. And we saw that in principle it can be exploited, this turbulence. So it's another kind, of course, again, is the power generated, because you are considering vertical axis wind turbines, because they need to be placed in the middle of the highways, and they are quite small. The diameter is very, let's say, should be of 0.5 meter or less than 1 meter. So also the produced energy is very small. But is
at least we can use this energy in order to light the street.
Yeah, so it's the same principle of when we saw this kind of machines here, and also this kind of, so the diameter, but they are placed in the middle of the highways, and there are some applications, but you must you must take into account that the produced energy is very, you can use, for example, to illuminate, to produce the energy for using in the lamps. So it can be, but it's something that can be in order to reduce the
From your viewpoint, actually, my idea will be developed in the future in order to light the street and also traffic light in the future. Is it possible?
Yeah, for example, we met a company here in north of Italy that was integrating this kind of vertical axis wind turbine with a small solar panel and then a lamp, which was installed in the street. So it was integrating both these renewable energies.
What their outcomes? Outcomes was good or?
Well, is just for reducing the consumption of the energy, so you can save energy, but is something is for low power application is something quite interesting. Yeah. Yes.
Okay. Thank you so much. Thank you so much for
okay.
brilliant explanation. Thank you.
So let's see some aspect regarding the energy and the control issue. So normally, in connection with this system, of course, the control system can have an influence in the total cost of the energy. So because, for example, of course, control it represents the first way for controlling the production of the energy. Another important aspect, because due to the control, is that it relies on a condition monitoring. So it's very important to check, to supervise the system, and in particular, because of course you can expect that if the system is stopped, you are losing money because it's something you paid it for, and then it's not producing money. So when it's not producing energy, so as soon as it doesn't produce energy, you are losing money. So it's a principle of the market. So it's important to integrate in these systems. So in the software, normally they are developed as a software tools, what we call condition monitoring. So they are systems that are able to supervise your process, and then, for example, detect faults. So faults is something that is, we will see later, that is happening in your system, and, for example, it reduces the production of the energy. So the cost, normally you are evaluating the effectiveness of your plant depending on the energy produced and the cost. So normally you think about the cost of the energy. And normally the design, so how you can design these systems can be enhanced by using some benchmark. So benchmark prototypes normally before starting building a real system, you perform a study on a benchmark or a prototype in order to understand how much, for example, energy you are able to produce, and also the effectiveness of your installation. And so, another important keyword is the reliability. So the reliability is connected to the probability of the faults and how much your plant is able to work to produce energy before a fault is affecting it. So it's a very important aspect. So normally we are studying what we call sustainable control. So sustainable control is a solution, or is a way for that helps your plant to produce your energy, to continue to work before the maintenance can happen. Normally, since we talk about the installation in the open sea, you can understand that it can be very expensive to rent a boat, a ship, for reaching your installation in the middle of the sea before, and then repair it in order to continue to work. So the maintenance of your plant can represent a huge part of the cost of the energy. Normally, the cost of the energy depends up to the 35%. We will see a slide later on the maintenance, operation and maintenance works. So it's very important to reduce the maintenance of your system if you want to reduce the cost of the energy. This is a picture of what can happen on your plant. For example, as we mentioned earlier, we know that due, for example, to the high speed of the wind, the blades are bending and then they can hit the tower. So this may happen. So you lose a blade of your system, and also it's very dangerous because it can affect also the safety of the people around the installation, especially if it's installed onshore. We have some examples here, some fundamentals, some foundations regarding FDI, FTC. FDI means fault detection and isolation. So fault detection means understand when a fault is happening, and isolation is the task of understanding where the fault is acting. So you understand which part of the system is affected by the fault when a fault is occurring. FTC means fault tolerant control. So it's a control that is able, let's say, to counteract for the effect of a fault. So I'm just now trying to focus on these aspects. So normally, when you are studying your processes, so here you have your plant. Let's imagine your wind turbine. You have your what we call fault diagnosis module. A fault diagnosis module, in principle, is a module that is, as you can see here, you have the plant with the inputs and the outputs. This module is acquiring the inputs and the outputs, so all the information from your plant, and is able, there are some design tools for obtaining the information on the fault. So the fault information can be used, for example, for what we call control redesign. So you are trying to counteract for the effect of the fault. So when you are estimating the fault, so you are extracting, you are able to use the fault information. This task is called active fault tolerant control. So active means, stands for here A, so active fault tolerant control. Active fault tolerant control means that in real time you are able to extract any fault information, and then you are able to act as a consequence of the fault. On the other side, and this is represented here from the outer bracket, in the inner bracket you have what we call passive. Passive is perhaps the simplest way for designing a controller. So it means that you, in principle, you don't have any fault information, and you design your controller without assuming any fault information. So normally this design is very conservative. So you are assuming that, for example, you can encounter, or you can have some classes of faults, but the problem is that your fault, which is acting on the system, doesn't belong to your class of fault that you are used for designing your control. Perhaps your controller doesn't work properly. So it represents a limitation. So the best solution when you want to design a control is to use let's say a strategy which is called active. So active again means is very important because active means that you have a fault diagnosis module that is able to reconstruct, for example, the fault information and then help you to understand which kind of fault is happening in your system, and then you can use it, for example, to redesign your controller and to modify your controller. So normally it's called also this task as controller reconfiguration. So you are able to modify your controller accordingly. It's really important. So I don't want to enter into the details because the mathematical focus would be very high, but it's just an information or a detail that I wanted mentioning. This is another picture I found on the web that is, again, a very important aspect of your fault. And also, as I already mentioned, when you want to perform the wind turbine maintenance, for example, think of reaching your, in the picture on the left, reaching your wind turbine, your offshore wind turbine in the middle of the sea.
Exactly. Think about this kind of a turbine.
Yeah.
That's right.
Yeah, think of, for example, you need to act immediately when a fault is acting, and maybe you need to rent this kind of boat, and it can be very expensive. So your cost of the energy is increasing suddenly. So it's very important to reduce this kind of...
This kind of the turbine, wind turbine, is fixed with the help of the soil at the end of the bottom.
Yeah, there is another, thanks for your remark. Yes, we have another, I will show it later, which are called floating wind turbines, which are floating on the sea. They are just connected on the soil of the sea with some cables, but they are floating. Is another important type of wind turbines. Yes.
Thank you.
And another, for example, maintenance work can be is shown in the picture on the right. Can be even more expensive to reach, for example, your nacelle, and an operator needs to go and check your nacelle. So normally this is a picture, a very simple picture of what we call the basic or a reference controller. So you have the wind makes rotating your blades. You have the drivetrain connects the generator, and then you have what we call the controller. So controller is something that is normally developed as a software program that, depending on the wind speed, is why there is like this dotted arrow, is controlling the blade rotation, and then acts on the generator in order to maximize the energy production. So also the technology I'm not focusing on the technology on the generation is another important aspect, but the joint use of
Could you tell us more about the control? I mean that if the wind turbine create the maximum energy in order to save the places, maybe save with something, the control try to stop the moving of the blade of the wind.
Yeah, the controller, for example, as I already mentioned, for example, with high wind speed, you have there is a very important and also it's very dangerous that, for example, due to the very high wind, the blades are bending and they can hit the tower. So the controller modifies the pitch, what is called the pitch angle of the blades in order to reduce the rotating speed. So this is one of the typical effect of your controller. On the other hand, for example, but is a technical aspect, the controller is, for example, modifying the pitching of the blades in order to adjust the generated torque, because the torque which is applied to generator is optimized in order to optimize also the generation of the energy. So it's another aspect that is managed by the controller. It's another technical point.
Can add to how much the energy can connect it to the grid network something.
Is also because, for example, the controller can also try to optimize the energy transfer between the generator and the power grid, especially if your system is connected to the grid. You need to have an optimization of the energy transfer. So it's a very important point when you need to connect. When the generator, so when your system is out of the grid, normally you don't have any problem, because, for example, you can store it on a battery, on a series of batteries, not very important. But when you are connected to the grid, you need to also maximize the energy transfer, understand when you want to transfer your energy. So it's another aspect.
We don't need to save the energy into the battery if you want to.
Yeah.
Connected to the grid.
When you are connected, so you are on grid, you don't need to store, and but you are immediately transferring to the power to the grid, and then the other users can exploit it immediately. Yes.
Thank you so much.
It's a very important here, just a picture, in order to show you some typical, as you can see here, some problems, some very, the safety, they are representing a very important aspect in the safety, because as you can see here, the blades were disconnected from the nacelle and hit for example, the ground, here the road, the houses, so it's very important. So in order to conclude this first part of this seminar, which was devoted to wind turbines, so I just mentioned it. We will talk about a little bit more tomorrow. We just mentioned this kind of fault detection and isolation and fault tolerant control modules in wind turbines that are really necessary. They are really required. Also, wind turbine benchmarks models are required, because we need to test for example, our solutions, because they can be applied to our systems, or to real systems. So we have FDI schemes that need to be developed, and together with the FDI, we have also FTC solutions that were proposed for especially with application to wind turbines. And so wind turbines benchmark, and also the analysis of the development of models for wind turbines systems is really important and challenging. For example, the one I mentioned, that it was launched, let's say, in 2009. It was the first proposal for this international competition. I will talk about it later tomorrow. It represents a very important step in the development of also the proposal of solutions for fault detection and fault tolerant control. So I think we can stop here and have a 10-15 minutes break before moving to the next part of the lecture, if you agree. I don't know if there are some questions before stopping. Also, if you want to contact me later or in the chat, I will be happy to answer